that should now, when that's complete, and you go back to File, Examples, have a look in the example code you have. Again, these are the basic ones. You'll see an Adafruit Circuit Playground. This is not the library not the project folder we're looking for. Keep scrolling down until you see the one that says Adafruit Neopixel. And I want you to open the one that says Strand Test. Strand Test, to someone that has never coded, will look a bit intimidating. It's got a lot in it. Don't worry about it. You don't need to know most of it. Those of you that do code, you can recognize this is basically the main program, and it just has a series of methods. So each of these statements here are methods that go out. They're method calls, actually, and these method calls access their methods, which are listed down below. So color wipe basically turns lights on in progression of a certain color. And so you'll see what each of these do once we get to TinkerCAD. Okay, so even though non-programmers especially don't need to know this program, you do need to know about two things. The first thing you need to know is this variable declaration. It's actually a constant. So anytime the code sees the word pin, it's referring to 6. And for our purposes, you need to know it because this is where the Neopixel will plug into the Arduino. So the data pin on the Neopixel will plug into pin 6 on the Arduino. And you'll see that again in TinkerCAD. So don't change that. If for some reason you couldn't use pin 6, I've had Arduinos before where like someone had broken a wire off into pin 6 so they couldn't use pin 6. If that's the case, you're welcome to change this. It could be pin 9 and then you do your wiring to pin 9. But I usually prefer to stay with the default. So keep that on 6. The other number you need to know about is this one. This first number represents how many lights you have in the Neopixel. So I'm going to put that in a comment too. The first number is number of lights on Neopixel. So Neopixels come in strips and rings and jewels, and you'll see that shortly, most of it. This definition here is an object definition. So strip is going to be the name of the object that is of Neopixel class. Anyway, what we need is to use Control A. That'll copy all the code. It will select all the code. So Control A, select all the code. Control C copies the code. And then we can head over to Neopixel. So let me get back to my desktop. Actually, let me open my browser. You can see I've logged into TinkerCAD already. So go ahead and log in if you need to do that. Sign up if you need to do that, but most of you have an account. So go ahead and log in and then switch to the circuits unit. And we're going to create a new circuit. And we're just going to, for now, we're going to just pull out a breadboard and an Arduino. We're going to close components for now. I'm going to rearrange these top to bottom as I usually do. And I know we don't have a Neopixel yet, but I want to go ahead and paste the code. So let's go to the code editor. And we're not using the block code, so click that button to make the block code go away. Now we're going to erase everything that's here, and this is important, especially if you're not a programmer. Make sure there's nothing in this code section before you paste. If you leave a curly brace behind, it will cause problems in your program. So make sure this is completely blank, and then go ahead and paste. And we're back to having the code here. So this code will now control our virtual Arduino. We're now going to close the code editor so we can get the Neopixel. So we will open components again, and you're not going to find NeoPixels in the basic components. They are listed in all components, but rather than scrolling, because there's a considerable number of components here, we're going to go to the search box and type Neo again, Neo. And then it shows the 5 versions of NeoPixel available in TinkerCAD. This is only a single NeoPixel, which is not as much fun as the other NeoPixels, although you can hook them together. But let's go ahead and take the biggest one, because bigger is better. And the great thing about NeoPixels, you can close your components, is that it only connects to one pin on the Arduino, and it only needs 5 volts of power. So it's perfect for an Arduino. And the fact that we have 24 lights and we're only going to use one pin is great, because otherwise we would need 24 places to plug lights on here. Or if you're using traditional LEDs and wanted to use 24 of them, you would need 24 data pins. But we don't need to do that. We can use one pin and still control all of these individually. So that's why NeoPixels are so great. Before we go ahead and hook up pin 6, we're going to zoom in a bit to look closer at the NeoPixel. You can see that there's 2 power connectors, there's 2 ground connectors, there's an out connector and an in connector. We'll use those in a moment, but first let's do the easy part and connect the, the power connector to the positive rail. And I'm going to have a red wire because I like to say consistent with conventional wiring colors. And therefore the ground should be black, so the ground connector goes to the negative row. Now, we know we need to use pin 6, but where does it go? Obviously, it must go in or out. So let's think about this. If our code is in the Arduino, we need to send it out of the Arduino into the ring. So we need a wire to go from pin 6. We could go directly to the in port, but I want to have you guys continue to practice breadboards. So we're going to take a wire from pin 6 because that's the pin we've defined in our code. I'm going to keep it green. So I connected it from pin 6 to row 12, but it doesn't actually matter which column you use. I meant column 11. So I'll just drop it here, column 8. But again, it can be in any column. Then take another wire from that same column you just dropped it in. Mine's now an 8, so I'm going to drag a wire from there to the in port because we want our instructions to go from pin 6 into the ring. We now have this properly wired. Technically it will work, but it won't work accurately. Let's flip back to our code editor because we need to tell our code that we're using 24 lights because we chose a ring with 24 NeoPixels. So I'm going to go to code editor. I'm going to find that line where I talked about the number of NeoPixels. Let me zoom that in. So this is where the NeoPixel component we're using is defined. Remember, this is representing 6. That's why we hooked it up to pin 6. This is the number of NeoPixels we're using. That wasn't supposed to happen. So 60 right here, it defaults for 60 NeoPixels. We're going to change that to 24 because we have 24 lights on our NeoPixel. So I'll zoom back out. I'm going to close the code editor and I'm going to click Start Simulation. And the simulation has started and the code doesn't work. I know why. Silly me. I forgot, even though I hooked these up to the negative and the positive rails, I forgot to bring the power and the ground from the Arduino. So I'm going to make a little wire from ground to the breadboard. And I'm going to take 5 volts into the positive rail. So the first time I tried to run it, the Arduino didn't actually have power because I hadn't made those connections. Now we do the simulation and you can see the lights going on. Earlier I talked about different methods within the code. Well, each method call within the code is doing a series of light patterns. And you can see sometimes some lights are on, some lights are off, sometimes they're green, sometimes they're blue, sometimes they're red. There's also rainbow patterns you'll see in a moment. And I got all of these just from taking the sample code that Adafruit provides with his library. And they're pretty cool, and they're much more exciting and dynamic in real life. You'll get to see that next week. One thing I've ignored thus far, I'm going to stop my simulation. So we have some cool lights going on, and I haven't really talked about this out port. This out port is because you're allowed to connect NeoPixels to each other. So we're going to go back to components. It should continue to show us our NeoPixel because our search word's still here. Let's grab a jewel and plop it in the middle of our big ring. And then recall what this wire is doing. This wire is taking the data from pin 6 and putting it into the outer ring. If we want to share the instructions from the outer ring to the jewel, we can take a wire that will take the instructions from out of the jewel, from out of the outer ring, sorry. So we need the code to continue out from this ring in to the jewel. So now our instructions will continue from the ring into the jewel. Of course, similar to what I did at the beginning, our jewel needs power too. So let's take this power notch, and we could connect it here, but that's the other reason there's a second power on a lot of these NeoPixel devices, because it can share power from ring to ring. So since this is power, I'm going to switch it to red. And then of course we have to ground, so I can take this ground to the ground of the ring, and I'm going to make that black. So I've completely wired up my inner NeoPixel. It's completely dependent on the big NeoPixel ring. If I run the simulation, we're not going to see any lights go on the NeoPixel jewel. Some of you may have realized already that our code is set up to light up 24 lights. This is 7 more lights than what we had. So we have to go back to our code editor, find that spot where it defines the number of lights, and change that from 24 to 31. You can now close the code editor, and now our code wants to light up 31 lights, so when I click Start Simulation, the jewel lights in the middle are going to light up also. And if I wanted to continue adding more NeoPixel components, I could add a singular one and take out from this jewel into the little one. So it's really nice that they daisy chain. And you're really going to like to see them when we do this with real components, but they're relatively easy to use once you get the library installed okay, and once you get the numbers straightened out. So try this circuit out on your own and let me know if you have any questions.